So today we're going to talk about two different approaches to harness design, right? And more specifically, creating manufacturing documentation to digitally capture the design of a wire harness. I would say that wire harnesses are probably one of the most challenging parts of the design process because they combine electrical and mechanical disciplines, and existing tools that are on the market for that are all come with their own challenges. Right? If you try to model your harness in your mechanical CAD tool inside of SOLIDWORKS, that's a very heavy model. It's an interface that's not familiar to many electrical engineers. And then other conventional methods typically used in industry include just using AutoCAD, Visio, those sort of things, and basically manually drafting those. And that means as designs change and things get manipulated, there's no automatic update of that process. Like I said, we're going to present two solutions today. Both utilize intelligent design techniques where we're going to reuse data, but the difference between them is one is a 2D only approach and the other gets us into the 3D world. So to start with here, Charles is going to show us a routine in SOLIDWORKS Electrical for creating a 2D manufacturing drawing of a harness based on a circuit design developed with SOLIDWORKS Electrical Schematic, which gives it a lot of intelligence, gives it that underlying database. Secondly, we're going to introduce a new tool called Enterprise Harness that's going to develop a 3D model of the finished harness that can be implemented and synced with the SOLIDWORKS CAD model. So to start with, to introduce SOLIDWORKS Electrical, SOLIDWORKS Electrical is a database-driven electrical schematic design tool. Right? It allows us to lay out and design the electrical circuit that the harness is going to serve, and it's going to enable us to apply a lot of intelligence and reuse components that we have in our library in that circuit design. So it's probably a good time to introduce Charles Mayu, our SOLIDWORKS Electrical Product Manager, to walk through a workflow to go from electrical schematic all the way to a finished manufacturing drawing in SOLIDWORKS Electrical. So Charles, I will make you the presenter here.
All right, sounds good.
Thank you.
So I've got SOLIDWORKS Electrical open right now, and hopefully everyone can see that right now with that there. Let me actually just adjust a couple things here before I get going. So I've got my schematic open right now, and I've got basically my fireplace controller. And nice thing is we're going to show you guys, basically Glenn and I are going to be working on pretty much the same design, just in two different realms. I'm going to be sticking within the SOLIDWORKS Electrical Schematic Professional realm. I will basically pass over some information to Glenn for him to use in the 3D environment. But for us to keep in this with the 2D only design, basically what I need to do is get in my connector that connects up to my controller board here, and then drop in my wires that connect up to the devices. And to complete that, I'm basically come up simple schematic, insert connector, kind of nice cool things that we do have inside of electricals. I can select create new one or select existing. I'm gonna go ahead and create a new one here. And I've got in my library, I've got some Molex connectors. So I'm just gonna go to my Molex group here, select that. Now I've got a bunch of them. Now the cool thing, because this is database driven, I do have a lot of search capabilities, and I can grab, such as number of circuits on this connector that I'm looking for. And I'm going to grab this connector right here. We'll go ahead and select that. And then I can give it a designator, basically, or tag. So this is going to be P1. And then it's going to ask me if I want to use a symbol. But instead of using this predefined symbol, I'm actually going to use a dynamic symbol, something that's going to adjust based off how many circuits I have. And I've got several different types set up in here. I'm going to actually go with this extra small one here. So let's go extra small dynamics. That would be really small. So let's go small with pins. That's a pretty decent one. We'll go ahead and grab that. And where my cursor is technically the first connection point. So I'm just going to place it right there. And you can see I've got the 1 and 1 connected up. They're kind of in line with each other there. So it kind of gives me a visual that those are going to actually connect and be connected. So now I can go ahead and drop in my wires for my component. So I'm just going to come up and say draw wires. And my wires are broken up by gauge and color in this particular project right here. So I'm going to grab my 16 gauge blue for my 24 volt DC coming in, and just go ahead and connect that up between those two. And I can come back in and grab my next wire that I'm going to use for my neutral or ground wire. And then we'll continue on for our other components here really quick. Just get this all drawn out. Now I don't have to connect up every single wire. I can pick and choose which connection points to actually connect up to, and I don't have to fill in every single one of them. It makes it kind of flexible for us. Like I said, you can break these out by voltage if you wanted to. In fact, in the actual defaults, it's broken up by voltage, but you can also do gauge and color if you need to. And I'm just going to grab a couple different colors here, and we're just going to go ahead and connect up the rest of these devices here and get that design, basically get our schematic finalized. And we'll go ahead and get that connected up, and then we will get our last one with purple. And we'll get this going. So we got that connected there. Now one of the things is this description is super long down here. I can actually hide that really quick by coming into attributes and just hide that description so it cleans up a little bit. I can move things around if I needed to, such as that can be moved over just a little bit to help clean it up. Now I do have my snap on, so it's moving things to fit based off that snap information. So there's basically my schematic with my wires. Now we do have a bunch of capabilities of doing design rule checks to verify if we have stuff. So if I wanted to add in, components not being used, components missing manufacturer's parts, all that type of stuff, I can add that in there. Manufacturer's parts assigned. Basically, I added too many manufacturer's parts and all that. Because the nice thing about this is with the database in the background, it is keeping track of all the parts, right? So I've got bill of materials grouped by manufacturer here. I got list of wires by line style, so it's keeping track of the wires and that type of stuff. Cables, if I have any cables. And then also a drawing list possibly there for me. And in fact, if I added a new one here, so I'm going to come in and actually before I add that, one thing I need to do is actually tell the system that all of my components, so actually I'm going to take and change this to a different location, component properties. So instead of being in the fireplace, I want to put this in my actual harness really quick. We'll select that. And what that does just kind of groups it out for me. And what I'm going to take is all of these components and assign those as being part of a harness. And the reason being is it's going to grab those wires with it and say that those are all part of H1. You can see I've already got some of them already in there, but we'll go ahead and assign all those as being part of that harness. Now I've got a report in here that I'm going to go ahead and add in, and it's a specific one that gives me my wire list that Glenn is going to use later on for our routing in the 3D environment. There it is right there. So wiring list. So basically what I got is harness, the wire color, the wire diameter, the section, the from component part number, the pin that it's from, and where it's going to, and where it's connecting up to, and that information is there for us. Now there's no wire number in here yet, or wire name, and that's because I haven't named it yet. So we'll come up to our process tab, and I'm going to go ahead and number my wires, and go ahead and get those numbered out. Now I have mine set to just number them 1 and then the color is what I have my formula set to, but you can definitely set those to be all sorts of different capabilities. Now there is some other ones in here. You can see it kind of pushed through on those. If we had to, we could renumber wires. If we move things around, wanted to modify them manually, like say I want to take this one and change it, I can override that and make it number 2 if I wanted to. So it's 2 red in that information. So it does give me the flexibility on that information also. So I pretty much have my schematic done. And and what I could do is take that report. I can export this to Excel, which is kind of cool. Gives me the ability to export that, and you'll see Glenn be able to use that later on. But what I want to do now is take this and show you how I can get a drawing for manufacturing without even having to go through the 3D environment. Maybe I don't have a full 3D model yet, and I want to be able to get this out for prototyping, right? So what I can do is come into my process tab, and I can use what we have is a 2D cabinet layout utility. Now I put my fireplace harness in a sublocation for this purpose, is to help group this out so I can show just the components that are in that harness. So I added another drawing over here in my document tree. I'm gonna go ahead and open that up, and we can go ahead and show this. This is just a normal drawing environment here. Now I do have some options to insert stuff up here, and I do have a scaling capability here. So I'm gonna drop this down to 1 to 2 on my scale. And all I'm gonna do is go ahead and start inserting my components. Now I have symbols associated with my manufacturer's parts here. Now I do have an orientation of this symbol. So right now it's in kind of an up and down orientation. I don't want it to be that. I want it to be left to right type orientation. So I can just right click and it will actually rotate that around for me, but you can also see it's changing over here. So I'm gonna go ahead and place this up top here, right about there for us. Now it does give me the tag of P1 with that, and that is the bottom, so it shows me which one is pin 1, 2, 3, and that information. Now as far as the end view, we'll save that for a connection label, which will actually give us a little bit more information for that. Now at this point I can come in and draw and start drawing out basically draw out my harness here. So I do have some keyboard input capabilities. Now one thing to keep in mind though is we are in a scaled environment, so it's going to change a little bit based off what I am. So I did a 2 to 1 scaling is what I'm at, so 1/2 scale. So whatever I draw in here, I want to make sure I type in that scaling in mind. So if I want this to be 10 inches actual length, I need to make it basically 20, or make it 5 inches long is what it would be. So I'll just come in and say at 5, 0. And I'm very similar to an AutoCAD or a draft site environment here with my drawing. And I can come in and draw here also. I can say, at say 5 inches again and 270 to go down and place that there. And I'll come back in and draw another line here and say the same thing. And basically what I'm doing is just kind of giving a guesstimate of where I want this stuff to be. And we'll come down, we'll say on this one, we'll go, at 3, 270. All right, and then we've got a little more segment here. And we'll say shift at 2, 0. And then for this last segment over here, I'm just gonna go ahead and freehand it really quick. And to do this, I'm gonna turn off my ortho and kind of just draw these out manually for this last set of wires going out to some fork terminals. And we'll just go ahead and do something like that. All right, so then we'll go ahead and drop in the rest of our components. So our P2 connector. Now I do have to understand and realize what I am actually showing here. Go to my other symbols. This one I forgot to actually associate. So here's my 2-pin connector. So we'll grab that and we'll go ahead and I'll bring this up just a little bit and kind of get an idea where I want it. So we'll go right there with that one. Here's my P2 and then my P4. Also do insert and go other. Select that one also and we'll drop that down here. And then for our fork terminals, last of our components here, we'll insert. And once again, I didn't associate a symbol with this one. I don't have an actual fork terminal, so we'll just use a spade terminal for now. That'll work. Get us close enough to get us an idea of what we're looking for. And we'll go ahead and place these right there. And we'll grab our spade terminal, place that one there. And place that one there. Okay, so there's all of our, basically our connections at our ends. Now, to get information about the actual connector and the circuit for that, what we can do is insert a connection label. So I can actually come into my P1, say insert connection label. And I've got some connection labels for connectors in here. And in fact, I've got one specifically for these connectors that I'll use. There's this one right here. So it's got P1. It's got the information from the end of that. Gives me the equipotential or the wire number and destination information. We'll add one for our P2. Once again, come back into our connectors. And there's one right there we'll select and use. So there's P2. And then we'll do the same thing for P4. Back up. That'll be for P4 over here. And 6, 7, and 8, I really don't need to because that information is coming from over here, 6, 7, and 8. So we're not really too worried about those individual ones. If I wanted to, I could definitely add a connection label for each individually one of those. Now, there's some other types of components that you may need for your harness design, right? Say some coverings. So if I come into the properties of my location, go to manufacturer's parts, I can actually add some other parts to this. So if I come in and search, and if I come in and go to some generic parts I have in here, and if I go into under my boxes and cabinets and come to ducts and then search, I've got some split loom here. So I can add that. I could say, you know what, I need 3, 4, say I need 4 of those. And then I can insert those as a duct. And the nice thing about this is that it will place it on the drawing, and then I can define a length. So I can say to there, grab my next one, insert as duct, and go to this section and place that there. Grab my next section. And this one needs to rotate 90, so we'll place it there. And I can say it goes to there. And we'll do this next one also. And if I turn on my ortho, that might help out. There we go. All right, so we've got all those placed there with our split loom. Now we may need something to keep our split loom in place, right? Well, come back into properties, manufacturer's parts, search, and if I remember correctly, I believe I have a wire tie. So let's just search wire. Oh, that's not going to be in there. Let's go any class. Yep, wire tie. It's under boxes and cabinets. So I can add, need 8 of those, right? So 1 on each end. So we got all of those. And then I can insert as other element. And I've got basically a picture of a zip tie here to insert. And I can just kind of get those placed where I need to. Now I've got my snap on, so it's making it a little bit hard to actually place that where I really want it to. So I can adjust my snap settings. I'm at an 1/8 inch. If I go 0.625, that'll give me a little bit more freedom of placing that. And we can place that right there. And we just go ahead and insert the rest of them the same way. And get those placed where we need it to. Now I do have the ability to add dimensions for this here. So if I needed to, I can say from here to there, give me that dimension. 10 inches. I drew that at 5, which gave me 10 because I was at that 2:1. Now you notice that I don't have any length here for my wires. I can adjust that from my schematic. So if I know that that is 10 and add another linear dimension here. I said that was 10 also. All right, so place that and I can move it back over. So 10 inches. So if I go back to my schematic and if I go to my wire properties, I can give this a length. Now it is showing millimeters here, but if I come up to my project, go to my project configuration, I can change the unit dimension to inches, apply that, come back into here. And for those of you that are using SOLIDWORKS Electrical, that's a new 2019 feature. So I can say, you know, that's 21 inches now for that wire. And I can come back in for this one, say this one's also 21 inches. And the thing is, if I add this information in here, it updates my report or my connection label here also. And it also will show up on my report. So length of 21 here. Bill of materials or my list of wires, it'll update in there also. Now those do show millimeters because that's what that report is written off of, but we can adjust that in the report itself too. All right. So that's kind of basic of everything. I don't want to have you guys sit there and watch me do everything here for us. So at this point, I could basically have all my drawings available there. Now I could go back to my reports and I can say list of wires from my harness. I can also add in a report that gives me list of bill materials for my harness. Let's see where that goes. Yeah, bill materials if used in harness. So I can grab that as a report. So those are all of my connectors. Now you notice I also have female crimp pins for my P2 connectors. So those are all there for me. All listed out. And I can take this and generate a drawing of this report if I wanted to. So that way that would go with my drawing of my harness. And ultimately there is my package. So there's my bill of materials used in harness. The mark. Now I could modify this so it combines information. So if we went back into our report, properties, columns, if I come to reference, I can tell it to merge duplicate, and I can tell it to not duplicate that in value. And what that would do is also not duplicate. So not duplicate. If we did that, it'll actually combine quantities for us and combine like components also. Okay. So we'll leave that at that. So that's kind of our basic of doing a 2D harness drawing without having to go to the 3D environment, but yet get all that information in there for us to know. There was a question in regards to how would you approach a situation where you don't want to show the entire harness to scale? Say that one of the branches is 10 feet long. Well, in theory, I can also come in here and override the text, right? So if this was super long, say it was 10 feet long, I can say that is, 120 inches. All right, so I could do that. I can override the value of the text in there. Okay. So that does give me the ability, just by clicking on the dimension, I can override it in the text value here. If I want that to go back to the default, I can go back to being blank, and that would put in the default measured value. So you do have the ability to override the measurements of that in there. Also, you can scale up individual portions of it. You do have the modify and scale command, so you can scale up the connectors. So if you do have a big harness that you want to be able to see the details of the connectors, you definitely can scale up and change that information available for you. All right, so that's a pretty simple, basic way of doing a harness design. Now with that, I am going to go ahead and pass it back over to Glenn for him to go over the enterprise harness solution, which will allow you to do the full 3D environment and get that for it also.
Charles just showed a workflow to create a manufacturing drawing for a harness completely within the SOLIDWORKS Electrical Schematic Professional software. Right. You have your automated pin tables, connector tables, lay it out on the sheet exactly as you need, all those great things for building that manufacturing drawing. And because it's database driven and electrical, if something changes, if you go to a different connector, that drawing will be able to be updated. But the one thing we're missing is the ability to estimate length, right? We don't yet know in that environment how things are going to be laid out in 3D space. And to do that, we need to go to 3D. So there are tools available within SOLIDWORKS for routing in 3D, but we hear from our customers over and over again that those tools don't meet their needs. They're either the models are too heavy to do, because SOLIDWORKS generates files that have a lot of data, a lot of information in them, right? So we hear that the load of having your whole model loaded means it's hard to do routing around it, or that 3D CAD imposes a lot of rules. And if you're new to mechanical CAD, to mechanical design, those rules can be pretty intimidating. Part mode, assembly mode, sketches, all those sort of things. So we have been looking for a long time for different solutions and different workflows for the electrical harnessing challenge. And we've been working with a new piece of software called Enterprise Harness over the last nearly 2 years now, and just getting started bringing it to market here in North America. It's based on a tool in Japan, developed in Japan and used by many, many household name manufacturers in Japan. And it's pretty unique in that it tackles the wire routing task in a 3D environment outside of SOLIDWORKS, right? It's a much more lightweight environment, and it means that you're not subject to the rules that come with working in SOLIDWORKS. It's got really simple, intuitive controls for manipulating things in 3D space, and it produces the manufacturing drawing that you'll need to complete your design. What we're really going to do here is combine information from my mechanical model, my SOLIDWORKS 3D model, with information from my circuit design. And in this case, I'm going to use an output from SOLIDWORKS Electrical that Charles just put together, but it could also be something you develop either in a different schematic design tool or develop manually. So let's go see what the process looks like. The electrical schematic that Charles just showed you is for this fireplace that's shown on the screen. And the elements that he was detailing in that schematic, really connecting the connectors in this model with each other. And there's some terminals here. To tackle that 3D task in Enterprise Harness, we first of all get out of SOLIDWORKS, but we want a picture of this geometry. So we use the button on the dashboard here to launch Enterprise Harness and load in this geometry. And so there we are. This is a lightweight representation of that exact SOLIDWORKS geometry. It's about 1/10 of the size, so it'll be kind of 10 times easier on your computer, 10 times easier to manipulate. And we've got full kind of feature tree here. We can turn things on and off. And I'm just going to turn off the firebox to start with. So my routing task is to connect these connectors together. And I could just tackle that manually, but because I want to know the pin-to-pin connections between all these items, the best way for me to do that is to import it, right? To import that from CSV. And this particular CSV here is a direct output from SOLIDWORKS Electrical, right? It's that harness one that Charles was working on with wire colors specified, wire diameters in place, the appropriate gauge, and then from and to pin and connector information, right? So this is automatically generated from SOLIDWORKS Electrical. I could also develop my own from-to list manually or from another package. So when I open that, it tells me kind of what I need to place. Now the software is smart enough here to know through a library building process that some of the items in this model are what we call hardware side connectors, and we just need to connect the appropriate harness side connectors to them. Now it's got plenty of smarts that if I drag this into the model, it will try and mount itself appropriately, but if it sees its partner it'll snap into place. So that relationship's part of the library build process. It makes that nice and simple. The next connector I have here, P2, that lives over here, and again, when it sees its partner, it snaps. P4 is over here, and then the last three are terminals that mount to these three ports. Right. And you'll see the little icon here on my equipment connector show that that's filled in. So that's good stuff. Now, the from to list I imported, which is just shown again here, has pin-to-pin information. So I want to read that into place also. I'm going to do that. And so here's the individual wires that now need to be connected straight from that from to list, right? So that from to list really saves me the effort of putting that stuff together at every phase. Right? It's understood by the software. It's can be reused over and over again, and if something changes, we can push that change through. Just a great question here from Eric. Thanks for the question. So basically saying, are the connector libraries populated by the user or provided? There is a small connector library that is in place in the software. It's also a service we can provide on startup to populate the most common connectors that you use to get going. But it's also about 90 seconds, 2 minutes per connector to populate a pair. So it's very, 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 very quick. So now my task is to connect all these things together. You'll see kind of a faint visual preview here, just giving me, as I click through the cables, what needs to be connected to where. Right? And if we wanted to take that default path, we could do that, but in reality, we're going to want to work around the 3D geometry. So we're going to route manually to start with. I'm going to add route. I'm going to start here. I'm going to come up. Try and get through that hole, maybe. All right, routing in 3D space. Anyone who's tried it is always challenging because you never know whether you're moving in and out of field. Right, but there we go. That's the start. Just routed kind of a general path in 3D space. Oh, I got through the hole. Not quite. The software is very, very flexible, right? If I pick a spot on the screen, it gives me some control points. I can add and remove control points at my discretion. But if I want to pull this through the hole, I grab one of these axes here and just pull it in 2D space. So now I'm going right through the middle of that hole. But in real life, I'm going to want to use clips and other things to retain it. So I do have libraries of clips available. Right? So I've got one that I've populated here, and I'm going to place this around the model at different locations where I want to retain the wire. I'm just going to place them. I'll get them right in a minute. Maybe one more here. Okay. So it's just put these in a default orientation. I can push and pull them around, maybe a little rotation here. Real life, I'd probably take more care on getting it exactly right, but just to move quick, I'm just going to put these in approximately the right spot. This one here is 90 degrees off. A little trick here, if I press the shift key, it'll snap that 90 degrees in one jump. Coming over here, another one. Missed the shift key, there we go. And then just a couple more to tidy up. get the right angle there. It's just a little bit of legwork to get these dialed in as I please. But now, the easy part to manipulate this, just a case of dragging that through dragging the wire through the connector there. You'll see it line up down axis. That's what we want. And now if I move the connector around, the clip around, the harness will go with it. And this can just be a lot more controllable. Just like in real life, you want it to be controllable, you want it to be locked to geometry. We can do the same thing, right? And I've got a bit of an issue there. Just kind of bring that back to an appropriate location. And I've kind of got a harness pathway I'm pretty happy with. Right. So there's that. Now, I've got branches that I want to put in place. Right, so we will make sure we capture those. Again, just go add route, and I need to connect this guy to the main trunk. That's done. I need to connect this guy to the main trunk. That's done. Oh, didn't quite get that one. Notice it's not coming out of the connector. So we'll go back and fix that one up. But I've got a couple more that I'm going to just make. Just get a little more careful with my clicks. All right, to make that branch. A couple that I don't want, I just delete. And this one here. Okay, so just to redo that, from the connector back to the main branch. Much better. And the same for this guy, from the connector. Okay. So nice and simple to add those branches. But there's no wires through this yet. There's one more to fix. From there to there. Got it. Okay. There's no wires down those yet, but to place the wires, because the software already knows, generally what needs to be connected, if it can find a pathway between these things, it will route it down the existing wire. So it's just a right click, mount selected cable on route, and if you're watching closely, you'll see the white preview change to follow a path around the entire circuit. Okay. And so what we've actually done there, while we're still looking at this pink overview, what we've actually just done is model individual wire pathways between those things. This is the actual design. The pink that we were looking at was just a simplified view. And look, we've got an issue here. If we want that issue to be more apparent, we can run check processes. We can run interference detection just to see where those problems are. So this guy is going to pull out in 3D space to fix that problem. Right, so that's very cool. Can start to add, the other elements that you might want to detail. Like a wrap around this. You'll notice that the diameter of this bundle changed with respect to the wire. And you also notice that my bundle's too big for my clip. Right, if that turns out to be the case, I can drag and drop, and this is a different style, but you get the idea. I can drag and drop a replacement, still too small. that'll go right in place. So very, very flexible in that sense. Okay, but what else? Maybe just kind of a retainer, just drop a band in place, kind of tie everything together. So now when I've got my final design, I'll say this is good enough. This is kind of what we're looking at here. Okay. So we'll call that done. And so there's two things that we can do with this now. The first is to push that design back to SOLIDWORKS. All right, so we have a push-pull connection with SOLIDWORKS 3D CAD model. When we're happy with that harness design, we push it back to SOLIDWORKS. If we make an adjustment in SOLIDWORKS to say the connector placement or the cutouts in the sheet metal, I can push that change back to the harnessing tool, and by pushing and pulling back and forth, can keep those designs synced and updated. All right, so you notice busily building SOLIDWORKS geometry, and when it is finished, we're going to have an associatively linked 3D representation of that harness built right into SOLIDWORKS. It's a dumb solid here in SOLIDWORKS. It's not directly editable, but we have this link element that's going to allow me to go back and forth if I want to update for mechanical design changes and vice versa. So with that done, the other place we can send information is we can take this drawing. I will take this 3D model and turn it in to a 2D manufacturing drawing. Okay. The drawing interface is over here. Just grab that layout. And here we have our CAD model. Right? It's kind of laid out roughly 1-to-1, and this goes back to the question that I believe it was Simeon asked earlier about getting this fit to a sheet. Right? So what we want to do is kind of just drag it over into place. This particular drawing is very, very flexible in that I can really scale things as I please. So I'm going to create a bend point here, just kind of so that I can drag in this arm and just shorten it up. Right? The dimension does not change, but my visual representation does. P2 I want to have connected, and then I've got 3 connections coming off here. All right. Last one, we'll just kind of bend around. All right, so whatever spatial layout I want to go for, that's not quite what I wanted. There we go. Get it spaced out as we wish on the sheet here. A couple of stray connectors. All right, maybe put a title block on. And this is one of 2 visual styles available. All right, so this is very kind of simple schematic style. The connectors right now are represented by boxes, but I can very simply drop in symbols. All right, so I've got some symbols here for different types of connector that I can plug in. So if I want to stick with the simple visual style, I can put my own connector elements in there, manipulate the labels. There's a great question from who's asking if we can put bill of materials in place, and we certainly can. Again, because all that information came from the from to list. I have a lot of that information in place. It's going to populate accurate lengths, include other metadata here. I can put this on a second sheet if I wish to, and also can put in a from to list, right? Just a summary of where we're going from and to. So put that down the bottom, maybe to place on a second sheet. So that's, like I said, one visual style. It's kind of very simple. The second visual style that's available is a little more pictorial, right? And so I can activate that. And so this will actually give you a pictorial view of the wires and the clips and the different elements, showing you what they look like with those same dimensions. And in this case, the connector shape is taken from the 3D model, right? So and I can rotate it for maybe a different view. I'm going to leave that one be. These ones here will be more interesting, rotated 90 degrees. It'll be more apparent what that is. And again, this can be manipulated and moved around to lay out as we need. That can be a lot closer here to kind of what it will actually look like when finished, but with accurate dimensions all across. So there's some very good questions here. One question is there a way to show individual wires in SOLIDWORKS? That's from Ryan. And the answer is yes. Basically, I just need to switch the visual style to this view when I hit the send back to SOLIDWORKS button, and they will be represented as shown on the screen. Now, obviously, it's a little more geometry, it's a little more time to process, and it makes it a bit of a heavier model. But yes, that can absolutely be represented. Mario asks if SOLIDWORKS needs to be open when you're routing the wires in SOLIDWORKS, and the answer is no. In fact, everything I've done, obviously I have SOLIDWORKS and Enterprise Harness on the same computer, but I can also save exchange files so that my electrical guys maybe could do this harnessing work and then send an update file over to SOLIDWORKS, to a mechanical guy using SOLIDWORKS. So that it can be disconnected. It's designed to be used by different design teams if needed. And then the last question I'll answer directly is from Simeon asking, what are the primary differences between this workflow and using SOLIDWORKS Electrical 3D? I'd say the main one is that SOLIDWORKS Electrical 3D is pretty functional for point-to-point wiring, for sort of industrial automation type workflows where you're wiring a control panel or PLC or some other control equipment. When it comes to harnessing with branching and splitting and generating flattened drawings of those, it has some serious limitations, and we typically don't recommend Electrical 3D in those situations. So just to wrap up here, we have shown you two approaches to harnessing today, and they're both geared towards that one goal of creating a manufacturing drawing to get these things made. So SOLIDWORKS Electrical, we're working entirely within a 2D environment. We can assign lengths to the individual elements, but we don't automatically know that that's going to be the true length in 3D. So we don't have that context of a 3D model. Now we can go measure a prototype or estimate, but it's a very functional drawing, a practical drawing for getting a harness manufactured. And then if we move to Enterprise Harness as an alternative, we are looking then at developing that true shape in 3D, making it part of the 3D CAD model for subsequent design purposes, and still developing that manufacturing drawing. So there are two alternate approaches. They really use two different pieces of software, although we certainly recommend that if you're going to use Enterprise Harness, SOLIDWORKS Electrical is a great front end for the circuit design. So with that, thank you very much, everyone.